All right, hi everyone. My name is Joe Marini. I lead the dev relations team on the Chrome apps and extensions platform. So I'm going to spend a few minutes talking a little bit about Chrome apps, and my colleague Andrew will come up after me, do a little more detail on what we're doing with PhoneGap and Cordova. I'm just curious, how many people use Chrome? Yeah, everybody uses Chrome. Who's heard of Chrome apps prior to today? We lost a few. Okay, that's good. That's great. A lot of people have heard of it. So this is my contact info. If you have any questions, you want to just say hi, you have questions about anything. Hey Joe, what are Chrome apps about? Hey Joe, what's that weird smell? Just please feel free to ask. So actually, you know what? Before I begin, let me just show some quick demos. So if you haven't seen Chrome apps before, essentially what they are is a way of using HTML5 to build native applications that look and behave just like real desktop apps, right? Kind of sounds like PhoneGap, right? Only in this case, it's for the desktop. So here's an example. This is The Economist. They built an app using Chrome apps, and I can just traipse through the app here. I can scroll through the content. Again, it's you see on the Mac they have the native menu bar. Well, you can't quite see it on the screen, but trust me, it's there. Works offline. Another good example. This is an application called Gliffy. It's a diagramming app. It's kind of like Visio. You can open up native files. So you can just like any native application. Yeah, so you can see I planned my itinerary using this app. Another good example, this is an app called Pixlr Touch Up. It's basically a photo retouching app. You can see that these guys didn't go for the native title bar. They just decided to implement their own. So I can open up photos. There's my bright shining mug right there. I can play around with graphics. Anyway, you get the idea. The idea is that these are all built using HTML5, and they look and feel native, right? In fact, you saw earlier as I alt-tab through the apps, right? They get their own icons. They show up in the dock. If I were to say, go to Searchlight or Spotlight, I can say, econ. You see it shows up in the search there. So the idea is that you build applications using HTML5 that on the platform they're running on look and feel native. And just by doing this, by virtue of building a Chrome app, I get 4 runtimes out of the box, right? I get Windows, Mac, Linux, and Chrome OS, which I guess is kind of like Linux. So what we're doing is we're building Chrome apps for the desktop, and we're also working to bring them to mobile via the Cordova project, which is what Andrew will go into in detail. So let me go back to the slides. All right, but why would you do this? Well, look, we're Google, right? We love the web. Web apps are fantastic. There's nothing wrong with web apps. Web apps are great. The problem is there comes a time when web apps aren't so great. Online, offline is one of those times. That's one problem. People play games on the web, right? Games on the web are fantastic. They're great. There comes a time, however, when games on the web aren't quite so great. You'd like to be able to use alternate input devices, right? This is really hard to do on the open web today, right? There's no really good, widely adopted way of using USB devices, for example, on the open web. So these are the kinds of problems that Chrome apps set out to help solve. So first, they run offline by default. So I take all my HTML code, my JavaScript, my assets, I bundle them all together, right? Put them in a really simple package. It's basically just a zip. And they're designed to run offline just by virtue of how you build them. Now, obviously, some applications only work really well when they're connected, but that doesn't mean that you can't have some functionality available when you're offline, right? Take Skype, for example. Like 95% of the value of Skype is only when you're online, but I should be able to manipulate my contacts or see my call history, right? So Chrome apps designed by default to run offline. They also give you access to the platform capabilities and the hardware. So our philosophy with Chrome apps is to leverage HTML5 and its APIs wherever possible. And when an API is not provided by the native platform, we build one. So for example, we've implemented APIs for things like USB access and Bluetooth. and UDP sockets, and so on. In addition, because of the way that Chrome apps work, and because the Chrome runtime, what we've basically done is we took Chrome and we factored out the browser UI from the underlying runtime, right? So now you can target the Chrome runtime just as if you would target any other runtime, like .NET or Java, Mac, whatever, right? So when you build your apps and you target this runtime, because of the way that they're built, so for example, my app could not even be running at the moment, right? My app is just sleeping, it's whatever. But the Chrome runtime is running because we keep track of the fact, for example, that you might want to listen for events like a push message from the cloud. So your server can send a push message through Google servers, which will then go down to the runtime. The runtime will actually wake your app up and tell it to do something, right? That's something you can't do that really on the open web today. If your app isn't running, you can't, wake up the browser remotely and have it do stuff. But Chrome apps can. As you saw, they give you a rich, immersive user experience. They're designed to run outside the browser. You have full control over the UI. We give you a full windowing API to use, so you can create windows to your heart's content. So all of that stuff is available to you as a Chrome apps developer. And for distribution and updates, we use the Chrome Web Store, but not in the case of Cordova, obviously. These are native apps. They go into Play. They go into the Apple App Store. But for the desktop version, they go into the Chrome Web Store. And updates are handled using the same infrastructure that Chrome itself uses to handle updates. So every few hours, the runtime will ping our servers and say, hey, does my app need an update? If it does, it'll come down. We also provide infrastructure for doing things like data syncing. So if you're a Chrome user, you've probably noticed that if you use Chrome on more than one machine, your bookmarks get synced across various instances of Chrome. We just provide that to you as a developer. So if you want to have data synced across your application on multiple instances of users' machines, we just give that to you. So you're using the same sync stuff that we're using for Chrome itself. So the structure of packaged apps, pretty straightforward, pretty simple. You build your app just the way that you normally would. So you take your HTML, your JavaScript, your CSS, all of that stays pretty much the same as it is now. All we ask you to do is put a little bit of infrastructure around it, right? So you build a manifest file. The manifest file handles things like what permissions does your app have, and what's its name, and what's its version, and that kind of stuff. Then you also define an entry point into your app. Again, this is probably not news to anybody. You're probably used to doing things like this anyway. But you provide a JavaScript file that handles a lot of the housekeeping, like what happens when your app starts up, what happens when it gets a message, that kind of stuff. And then the background HTML file is actually, it's just a host for the JavaScript. If you don't provide it, we just make one for you. So you really only need the manifest and the main.js. So that's pretty much how Chrome apps work. And what we're doing with Cordova, we have a team in Waterloo that's working on taking the APIs that we're implementing for Chrome apps and bringing them to the Cordova runtime. So for example, the things like I was talking about before, like the syncing API, things like identity management. Who loves writing OAuth code? Yeah, me neither, right? So we've actually built APIs to simplify that stuff, and we're taking that and we're bringing it over to Cordova so that you guys can use it in your apps as well. And Andrew will get more into the stuff that we're doing there. So what I want to do really quickly, so if you're interested in this, the URL there, developer.chrome.com/apps. And by the way, these slides will be available, so you don't have to scurry to write this down. I'll make sure that this is all available. But that's and I'll show the site just in a second. So what we're doing is we're using that site is the clearinghouse for all this information. Let me just jump over there right now, and I'll show it to you. So that's this site here. This is where all the docs are. One of the things I really quickly want to show is, so I mentioned earlier, we have a whole bunch of APIs where we fill in places where HTML5 does not provide APIs. So for example, things like alarms, native context menus, the file system, and so on. So these are things that, now, and to be clear, even though these are APIs that are provided by the Chrome platform, everything that we're doing with an eye towards eventual future standardization. Like, there's no reason why anything that we're doing has to be proprietary. All the work that we do is open source. It's all in Chromium. Anybody can fork what we do and take a look at what the source is. So there's nothing untoward about any of that. These are just APIs that we provide in the interim until HTML5 can either implement them themselves or catch up or whatever. But you can see there's a list of APIs here that we provide to handle various features that browser runtimes don't yet do. The other thing I want to quickly show is our GitHub repo. So if you're interested in playing around with this, we have a bunch of samples on our GitHub. Just go to Google Chrome/Chrome Apps Samples. And pretty much if there's an API, there's a sample for it. So these are available for you right now. Just download them. Working with them is actually pretty easy. All you need to do is inside of Chrome. In fact, I'll just show this to you. Let me jump over to the Canary build really quick and close some of these windows. And let me just bring up there we go. So as a developer, the development process is pretty straightforward and simple. All you do is build your app in a folder, just like you normally would locally. And then when you're ready to try it out, you come into the Chrome //extensions page, and you just click on Load Unpacked Extension, point it at the folder of code that you want to work with, and it'll load it in this list here. And then I can just debug this as any other app. So let me just launch one of these. Okay, here's the Hello World example. So when I launch this, you can see the app comes up. And if you're used to using the Chrome developer tools, then the good news is you get the exact same developer experience that you would if you were working inside Chrome itself, right? So all the tools that you're used to working with, you can use the same ones to debug and work with your Chrome apps. So let's see, how am I doing on time? Yeah, looks like I'm pretty much ahead of schedule. So that's pretty much, in a nutshell, what Chrome apps are. I'm going to let Andrew talk more about details, but before he does that, are there questions about any of this? Yeah. What's the difference between an extension and an app? Yeah, so the page is unfortunately named. It's named the extensions page, but this is where apps in the in the build process are listed. Yeah. Well, the main difference between an extension and an app is an extension extends Chrome itself, whereas an application, a Chrome app, is a standalone thing. It's not part of the browser UI, right? So that's the main difference. Other questions? All right, well, if you think of any, I will be around. Just please come ask. I'll be hanging out somewhere for the rest of the day. I'll be having beers later, so please come and join me. You saw the diagram. I'll be doing that. So please come join me. So, all right, thanks, guys.
Thank you, Joe.
Yeah.